Hello, in this video we're going to look at Rust Axum BDK. We're going to be looking at Axum 0.7. I was working on a project where you're using Bitcoin Dev Kit and was integrating it with Axum, but I've modified it to work with the latest version of Axum. Previously it was 0.6, so I've gone to 0.7. I've been using logging. I've been using descriptors, which are a feature of Bitcoin Dev Kit. If you're not interested in Bitcoin, this is still valuable because it teaches you, or it forces you to learn how to read JSON, parse it, use it in your code. And we'll also be looking at extended private keys. So if you've seen my website, Red and Green, I've got an article on here called, go to the top, BDK wallet descriptors. Basically, they are a way to recreate your wallet. A wallet can be physical or it can be in software, and it's a way to generate Bitcoin keys. And once you've generated a Bitcoin key or public-private key pair, you can give your public key out. Basically, the public key is formatted into base 58, or it's also now BEC32. So although it's called a Bitcoin address, under the bonnet, it's actually derived from your public key. So you give out your public key, and obviously you hold on to your private key. Your private key is derived from your extended private key, which is XPRV. So whenever you see XPRV in my code, it's an extended private key. An extended private key enables you to make multiple private public key pairs from that original. If you imagine a tree structure, it's the very top of the tree. So you can actually create, I believe it's 2 billion addresses, something like that. Anyway, just a quick note, when you generate these addresses, it typically generates 100 for you. So it's quicker to do them in batches, apparently, and also it's good for security because then you've got 100 chance of 1 in 100 being the one that's somebody trying try and copy or use or something. So I've used BDK CLI. So there's the BDK, the Bitcoin Development Kit, which is written in Rust. It's available for other languages to use, but it's primarily, it's developed in Rust for use as a Rust crate, but also there is BDK CLI. So it's basically if you think of like Python where you write your code, but also you can run Python from the command line. So yeah, you've got BDK CLI as well. So you would typically type BDK-CLI and then you could do key generate and it would generate you a key. When I say key, it'd actually be generating you fingerprint and a mnemonic and an extended private key. The mnemonic is, you may hear people talk about 12 words or 24 words is your seed phrase. Those words get mapped to numbers, and then those numbers get padded out, and then they get hashed, and ultimately you end up with a private key. And then the private key obviously enables you to use the elliptic curve, which can then generate you a public key. So you hand out the public key, people can create transactions and send to your public key. And then when you want to spend your unspent transactions, you need to then unlock them using your private key. So anyway, enough of that. Let's look at some code. This is actually the .toml file. So I've used Axum 0.7. I was partially inspired to do that by the recent Jeremy Choan video. If you hear me mention him a lot, I do find his videos really well made and really good reference. And I think Axum is just, if you've ever seen my Python 360 channel, I did get into using Fast API a lot. So yeah, I do like creating or attempting to create APIs. Tower, Tokyo, and Axum all kind of work together. Serde, so serialized, deserialized JSON. Tower cookies, so again, Tower I won't cover that here. That's slightly beyond my knowledge at the moment. RSTML, that enables you to kind of use templates and create nicer HTML actually inside your Rust code. And we've got env logger and log, which I've used logging here, and I'll talk about that in a bit because it actually helped me, but also it hindered me at one point. So let's actually look at the code. That's my README file. So yeah, just I, I made a mistake. I actually thought BDK needed to use a database, so I started looking at SLED, but it actually doesn't. The all of your keys, which you which you can either hand out as public keys or your private keys, which you need to then spend any transactions that were sent to your public keys, those are actually just regenerated or created from your extended private key. So once you've got your XPRV, you can then do the rest from that. So if you look down here, the XPRV is basically JSON format. So XPRV is the key, and then the value. So this is on the test network. So don't get excited that I'm kind of advertising my private key and I'm being stupid or anything. I can be stupid, but I'm not that stupid. Network testnet. So all I'm actually storing, I created a struct in my code. So the code actually stores the XPRV and it stores the network, which I then use that struct within my code. I've got these endpoints, so just basically the root, and then I've got gen wallet and load wallet. So gen wallet will create a wallet from scratch and then generate some addresses, and then you can send some test Bitcoin. So you'd need to go onto the faucet. So the faucet is the numerous faucets out there, which are actually replicas. How can I best describe it? Look up faucet. I can't really explain faucets very well. They're basically equivalent to they're like a Bitcoin miner kind of, and you can get test Bitcoins from them to use on the test network. It's basically a test network. Let's look at the code. So I'm creating a Bitcoin wallet, and also so that's the gen wallet, and then I'm also just loading a wallet. So when I load the wallet, I load it from this because this XPRV enables me to regenerate. Let me try and show what I mean here. So get out of this. I nearly did the classic trick of not being able to exit Vim there. Sorry about that. Right, so if we go to source, we've already looked at the cargo. Cargo, let's run it and then I'll show you, and then I'll talk through the code after. So it's listening on port 8080. Localhost 8080 / API / So I want to do load wallet. What that's going to do is it's going to load the extended private key. Sorry, it's going to load the JSON file, and then it's going to pass out the extended private key, and then it's going to use that to create a new wallet and create some new addresses. So let's see. There we go. So the amount is null. That's because I've put in amount into the struct for actually sending transactions and how much do I actually want to send. But ignore that for now. The message is actually that's the BEC32. That's the SegWit address. So if you know about Bitcoin, there used to be base 58 longer addresses, but then SegWit came along and now there's like the shorter format. And then you can see that address there. That's actually what you just saw. So it begins with TB1 and ends in 0A. Yeah, TB1 ends in 0A. Now that's loading the wallet. So if I cancel this, and then if I run the code again, and then if I come across here, and if I refresh the page, so it's obviously going to send a new request, I actually get the same result. And that's because it's used the extended private key. I don't know if that's going to help. Yeah, so you can see it's a new request and you get the same result every time. So you get the same result because you're using the extended private key. If I run this, let's run this again, and I'll just demonstrate that if we did gen wallet, we'd get a different address because gen would use a random number. So each time it runs, it will generate a new wallet and it will generate a new address. Because that's intended to only really be run the first time you would use your wallet. So each time we run it, we get a new address. See, P0U, OOW, so on. Okay, so that's what it does. Let's look at the code. So actually, if I just do tree -l -2, yeah. So you can see I've got the JSON file, which we'll look at directly next. Then I've got an error RS, which handles the errors. We've got main, which is main entry point. And then I've got mod, which then says go and use routes.login RS. This was initially inspired by the Jeremy Chone Axum video, but I've kind of gone off and added, taken away, and it's kind of morphed into my own code now. Let's look at the JSON then. So if we do view wallet JSON, that's the extended private key. Where did that come from? Little tip: don't use ChatGPT. ChatGPT will give you a nonsense descriptor. So don't use ChatGPT. Create your own with BDK CLI. Or if you don't want to do that, what you could do is you could actually use my website, and if you go to red and green, you'll find. Let me just show you. Yeah, you could copy and paste mine from here. That works. That extended private key works, and that's what generates the same key each time, same public private keys each time. If you use the ChatGPT one, you get a base 58 encoding error. So yeah, don't use ChatGPT 2. I mean, it's one of the things. Let me talk about the main code now. So if we go to web and then let's open up routes, because this is where most of the code lives. You see a huge amount of imports. Probably quite scary if you're new to Rust, but yeah, necessary evil really. You could just kind of use star to import just en masse, but obviously that's not very efficient. So yeah, don't do that. I've used a constant here, so the name of the text file, wallet_config.json, that's the file we just looked at. Here, I've got, see this here? Read file content, and basically it's doing a read to string on the JSON file. And I've just created a new new string called config_content. Then the function returns the content of that file as a string. You see the IO result is a type string. So I call this, but notice here it's just fn. It's not async. When you use your own function inside of something that's already async, then you don't need to have the inner function that's working inside it. That doesn't need to be async. Well, that's how I understand it. That works. So if anybody knows differently, I'd be interested on whether you would put an async function inside another async function. I've not seen that. Okay, so these are the routes. So these routes, so we've got public function routes, and that's what gets used in main. So main just calls that, and then depending on URL, whether it's yeah, login gen wallet. So the login is obviously post, but the other two are just get because I'm just trying to generate a wallet or load a wallet. That's for the login. That's pretty much lifted from the Jeremy Chone video, so yeah, no credit to me for that. The struct that is used for that is just username and password as string. So this is new. So I've had to create a struct which contains the extended private key, which as you saw was in double quotes, so that's a string, and network, which is of type network. Now, where does that come from? That comes from BDK. So use BDK Bitcoin network. And then this is the good bit, really. So Gen Wallet, which I think I've shown in a previous video, and it's documented on my website. So I'm more interested in showing off the load wallet. Let's just make font just a tiny bit. Is that too big? It's probably okay, isn't it? No, let's leave it at that. Hope that's okay. So again, query param, so I can pass in the amount. What am I passing in? Passing in. Potentially, I'm passing in a new wallet address and amount. No, I'm not. This is a GET request. In actual fact, it doesn't really need to be a full-on query, but I did that kind of for future ability where I could be then passing in several key pairs. So that's why it's a hash map. So like a Python dictionary. So yeah, the key is a string and then the value is a string. So xpriv is a string and then the value is a string. So network. Sorry, we're looking at Gen Wallet. What am I doing that? Here we go. Load wallet. Sorry. So yeah, we've still got the key value pairs for the query, and we're still returning JSON. We're returning JSON. You saw that. You can see that here. That's the JSON that we return. So this is the good bit, really. We're actually getting that we're reading the file content from the JSON file, and then it's going to be of either type string or an error. And then we're going to match. So we're going to say if it's okay, then we return the content. So config content equals content. Else, otherwise, it's going to be an error message. Obviously, with this type of result enum, then the okay and the error both have to be the same. So in this occasion, you've got content, and then you've got error there, which is a string. No, that's not being returned. Sorry, that's printing, and then I've got it's returning JSON here. So yeah, the content is JSON, and then the return is JSON. So that's JSON, and then we've got wallet config. So we're actually converting the content, the config content. We're converting that to JSON, and then once it is JSON, then we can extract the extended private key, and we can extract a network there. So extended private key will be T1 PRV blah blah blah, and the network will be testnet. So that'll be a string, and they'll both be strings because that's what extended private key will be a string, the network will be of type network because that they will then match what we've defined up here in our wallet config struct. Nearly there. So once that runs, that gets us all our variables that we need to then pass into our wallet. So then we create a new wallet. So we're creating a new wallet during this running of the API. So once it exits, then that wallet's gone. But when you start up Axum again, then that wallet will get read from the JSON file, and then it will get created. So although it's kind of weird to think of a wallet being destroyed and then being created again, but it comes back the same. So when you generate a wallet from scratch, it's using random numbers, and that's obviously unique. But when you do this, so when you load the wallet, it comes back the same because it's using the descriptors. BIP84, BIP84 descriptor, and then it's always got the 84 in it. And these numbers here, the forward slashes, reference each time it does another forward slash, then it goes down to a child and then a grandchild and so on. And the naught that's the index number. Yeah, beyond what I want to talk about here or what I know about mastering Bitcoin, read that. So here, this is what caught me out before. I was thinking in terms of, well, if there's memory data, if it's only in memory database, then you're going to lose all the information. But I was being stupid. The information is actually or when I say the information, the public-private keys are recreated from the descriptor, and the descriptor obviously is in the JSON. So I'm not even going to get into security here, but obviously you wouldn't just have a flat JSON, you wouldn't just have a JSON file on your wallet, because if someone gets hold of that in plain text, then they've got your extended private key, so then they've got the potential to then regenerate all of your to recreate your private key and public keys and so on. So this is all for didactic purposes. So yeah, we're going to brush kind of security under the carpet just for this learning exercise. But yeah, you really do not ever want anyone having your private key, because that's the same as giving somebody your PIN number for your bank, for your cash machine for the bank. That your account would be empty. So the new wallet is actually takes that wallet object here, and it does get addressed. So it's basically generating it gets you a new address, and then it just increments the derivation index. Um, and then this is just here for display purposes. So this is what gets returned, and that's what's actually then getting displayed on the screen here. So or it was when it was running. So even if you're not interested in Bitcoin, this is good for passing JSON. It's good for logging. Oh, I didn't show you the logging. Let me just cover that before I wrap up. So Rust underscore log equals info. I'm in the wrong level. Let's just go up one. So Rust underscore log equals info, and then you do cargo run. If you can spell cargo properly. Right, so that looks the same at the moment. Let's just move this across onto. Oh, I can't do that. That's annoying. Normally you can move on to another workspace, but I don't think Opera lets you. That's weird. Right, anyway, let's run it. So that's generating the wallet. So if I run that again, we should get a different address, which we do. And here we get, you see the additional info we're getting? We're getting the green info. And this is interesting. Derivation of 100 addresses. It took 189 milliseconds. So yeah, Rust is fast. That's actually done quite a lot of stuff under the bonnet as well. Wow. So that's doing generate address. Okay, let's just do load address, and then I'll leave it there. So load wallet. I did a hyphen. It should be an underscore. There we go. Go back and look at error messages, or sorry, the info messages. So the first time we were doing derive. That's odd. It's done. Let me just run this one more time, twice. Okay, so when it runs the gen wallet, it creates the new addresses and it creates 100 addresses. When it's loading the addresses, it's loading. So here we see it's creating the first address. It only displays the first address, so it reveals the address. So it's FW, and there it ends in FH. And here we go. This is when I was doing the load wallet. And do you see here? It's the same address each time. So it's loading based on the extended private key, which is the same each time. Because the extended private key is the same, because it's loading it from the JSON file rather than randomly generating it, based on that extended private key, you then get the same address. So the address is basically based on the public key, which is derived from that private key. So that's effectively derived from the public key, which matches the private key, which is derived from this. So public private key pairs are fundamental to everything here. Whilst just on that subject, I'll just quickly show you just something. I was tinkering around just with Streamlit in Python, and so that's the Python code. I actually wanted to test Streamlit versus Rust, but I ended up just getting into a bit of a mess trying to recreate something identical in Rust to what I'd generated in Python. And Streamlit is kind of very quick and easy to knock up, whereas I would have had to done HTML, JavaScript, and all that for Rust. So anyway, this is the private key. So the private key gets randomly generated here. Once you've got a private key, it will always have a corresponding public key. So that's the public key. So if you think of kind of yin and yang or a two-piece jigsaw, that's jigsaw piece one, and that's the second piece of the jigsaw which completes it. So this is a demo of the digital signatures. So with digital signatures, you have you sign the message. So the message is, say, hello Rust stations. Now that I sign it, it's going to sign it using my private key and the message, and it's generated a signature. And now, if somebody wants to verify the signature, they don't need my private key. They just need the public key, which I can distribute freely because it's not something which is going to allow anybody to do anything or alter anything. All it's going to do is allow them to verify. So if I do that, signature is valid for the provided public key. So I can hand out that public key. That public key can only be created by somebody who holds this private key. So that's kind of the fundamental building blocks of Bitcoin. To be able to spend money which is sent to your public key, you need the private key. But if somebody wants to check that if somebody wants to verify, all they need is the original message plus your public key. So enter the public key in the hex format. So that's just kind of a little thing I knocked up in Streamlit. So yeah, there we go. I hope this has been interesting, and I know it's not pure Rust, but it's almost time, I think, to kind of why has it done that? No, I keep getting this. I don't know why. maybe it's because I've got my quick dev running in the background or something as well, and it's, I don't know, but yeah. Anyway, so if you want to look at the code, it's all on my GitHub repo, and it's under BDK_3. It's kind of my third attempt. And those are the endpoints you can test. You could download this code. You can run it. You could do cargo, clone the repo, then just do cargo build, cargo run. And once it's running, you can just hit those endpoints and test it. And you can also use my extended private key. That JSON file will already be in the correct place for you. So when you want to run it, just run it from the source folder, because it will need to, it's looking for relative path of wallet config JSON at that level. And that's the extended private key. If you want to create your own extended private key, then probably the easiest way is just to install BDK CLI. And if you've not come across that before, then just Google for BDK Bitcoin Development Kit, and you get a link to install BDK CLI, which is basically it gives you the same functionality that you can then do with the code in Rust. So kind of prove it using BDK CLI to generate the address. You can then generate a wallet, create a transaction, sign the transaction, and then you broadcast the transaction. And all of those will just need you to get some dummy or some test Bitcoins from, you can do that from Google as well. You just need to search for testnet, Bitcoin testnet, faucet. If you want to see all the documentation about using the faucet, let me just show you my article here. Again, it's all documented on here. Start with this one, Learn Bitcoin Dev Kit, and that's the faucet. So just watch out for the dust limit. If you think, oh, I haven't got many test coins, I need to be sparing with them, you do actually need to send at least 546 Satoshis, otherwise it's below what's called the dust limit. Because each transaction needs to be of a certain size, otherwise it's not worth the time and effort to include it into a block. And that's on the test now. Obviously, on a real Bitcoin transaction, then it's a lot more. I think it can be something like $5 or something to get included with a transaction. Up to 2, 3, 4, 5. I'm not sure. I think it varies a lot as well. So, but typically, if you're transferring Bitcoin, the idea is that you use Lightning Network to pay for coffee or McDonald's, and any main network transactions you make typically would be for kind of hundreds of dollars or pounds, because that's kind of your big savings. So yeah, look up Lightning Network if you want to. So Lightning Network basically sends smaller amounts of Bitcoin, and it's much lower fees. And you can do that from your mobile phone. And for instance, I helped somebody on Twitter once with some Python code, and then they just sent me the equivalent of about $10 if you converted it. But they just sent me about $10 worth of Satoshis, and I've just got that on my wallet of Satoshi on my phone. So, and then if I want somebody else to help me with something in future, or I can then send them some on Lightning. So yeah, Lightning is smaller amounts of Bitcoin. So it's still the Bitcoin network. It's still the Bitcoin. I wouldn't say currency. It's still the Bitcoin units of value, shall we say. So yeah, thanks for watching. I know this has been a bit of a longer video than normal. Hopefully it's given you kind of some inspiration to look at Axum, maybe to use BDK. And with Axum, I've now used 0.7, so it's the new format where you've got Axum serve, and then you've got your listener, and then you've got your app, and you also use Tokyo Net TCP listener now. And you can just set the address much more cleanly now. You don't have to worry about the extra pairs of parentheses and the square brackets and so on. So yeah, there we go. Thanks for watching, and I'll be back soon. Don't forget a thumbs up if you like these videos. I know this has been a bit of a longer one, not quite so structured, but there was a lot to kind of talk about while it's all fresh in my mind. And yeah, if I made it too much like a lecture, it would be boring, and I haven't really got the expertise to be a lecturer. This is more kind of showing you what I've been learning, and hopefully you can kind of get something from it. Thanks for watching.